All right, in this video, you're going to be making your greatest common factor GCF card, or the GCF section of your factoring all-in-one card if you want. And what a GCF greatest common factor is to divide out as much as possible from each term so that we're dealing with smaller terms and numbers. So in general, it's easier to work with smaller, less complex terms and numbers, so factoring is no difference. So we want to pull out as much as possible and work with an easier polynomial. So we're going to be looking at this problem, negative 12 x to the fifth y minus 15 x to the fourth y squared plus 18 x to the third y to the third. And we'll be writing out our steps. Our first step is to find the biggest number that goes into each of the coefficients. And if my lead coefficient, once I have the polynomial in standard form, meaning the exponents are counting down from highest to lowest, if that lead coefficient, that first coefficient, is negative, I do want my GCF to be negative as well. I do want to pull those out along with the numbers. So I have my coefficients, which are 12, 15, and 18, ignoring the signs of them because I'm going to deal with that lead coefficient. So I just really want the number part, not the positive or negative of it. So we're going to list each one of their factors in order, starting with 1, and then we're going to look for the biggest number that's in each of those columns. All right, so I have all of my factors, which are 1 and 12, 2 and 6, and 3 and 4. Those are all the numbers that go into 12. 15 is just 1 and 15, or 3 and 5. And then 18 I can get by either 1 times 18, 2 times 9, or 3 times 6. So looking in each one of those columns, I am looking for what number all of them have. And if I look at it, I can see 6 is in 2 of them. It's in the 12 and the 18, but it's not in the 15. So the biggest number that's in all 3 of these would be that 3. So for my GCF, I'm going to start with that 3, and I'm going to make it negative because that lead coefficient was negative. I'm going to put it a little beneath my problem, and then I'm going to go to step 2, which for step 2, it's going to be find the letters or variables that each term has. So in this problem, I'm going to look, and they all have x's and they all have y's. So we're going to be writing that down for our GCF next. So we've looked at the letters, and then we've written the smallest exponent for each. So remember, any variable that doesn't have an exponent has an exponent of 1. So the smallest exponent I have on the x is a 3, and the smallest exponent I have on the y is the 1 that was missing, and I just wrote that in. Okay, so that's all the steps to get the GCF. So that is the biggest amount I can take out of every single term. And now the next step we're going to do is we're going to divide each one of our terms in the original polynomial by that GCF. So then the next step is to divide each term by the GCF. So I'm dividing every single term by the negative 3 x to the third y to the first. And then I'm going to follow the rules of exponents to simplify each one of these fractions. So doing the reducing, I have negative 12 divided by negative 3. Negative 3 goes into both. Negative divided by negative is positive. 12 divided by 3 is 4, so 4 is going to be on the top. And then with the exponents, I always, since there's exponents on the top and bottom, I'm always going to be wherever there's more, and I'm going to subtract however many were on the other side. So for the x to the fifth, it's going to be x to the fifth minus 3. And the y, it's going to be y to the 1 minus 1 because there was 1 y on the bottom. Going to the next term, it's going to be a negative divided by a negative is positive. So 3 does go into 15 5 times. And then do the same thing with the exponents. There's more on top. So the exponents for the x is going to be 4 minus 3, which will be 1. And the y's, there's 2 on top and 1 on bottom, so it's going to be 2 minus 1. And then looking at the last fraction, it is going to be a negative divided by a positive divided by a negative is negative, and 18 divided by 3 is 6, so it's going to be a negative 6. And then I'm going to have, there are 3 x's on top and 3 x's on bottom. I can either subtract it or just cancel them out. And there are 3 y's on top and 1 on bottom, so it's going to be y to the 3 minus 1. All right, so showing the where the exponents came from is in orange. And then my final answer for this problem, it is not fully factored though, because I still, once I pull out the GCF, I do have to check what's in the parentheses to see what else I can factor. And in this case, I can't actually factor the inside stuff, but that will be on a later card. So my final answer is going to be the GCF first, and then the rest of the polynomial. So it's -3x to the third y times the quantity 4x squared plus 5xy minus 6y squared.